Hey guys, today let me introduce you to Edify Right, a website that has video solutions for topical past papers from IGCSE math. Here you can search for different IGCSE math topics, pick the year and watch the detailed video solutions. You can even download the marking scheme. All of this is completely free. There also is a feature for group discussion, so if you have any doubts, there is always a group of dedicated educators that will help you out with your doubts and questions. And if you're wondering how to access this website, the link is in the description and you can access it for free. The table shows information about the mass in kilograms of each of 50 children. So here we have mass and here we have frequency. The first question is complete the cumulative frequency table. Okay, so all you have to do is just keep adding on the frequencies. So this 3 remains 3. The second box is 3 plus 19, which is 22. The third box is all of these combined, so that is 43. The next box is plus 5, so that is 48, and then plus 2, which is 50. So this is the table for cumulative frequency. Now on the grid, draw a cumulative frequency diagram to show this information. So give me a second, I'm just going to plot all these points. So here you have the coordinates, right? So you have 3, 10, 22, 25. You have it the other way around because the y-axis is cumulative frequency and the x-axis is mass, right? So you have this as x coordinates and this box as y coordinates. So it's 10, 3, 25, 22, 35, 43, so on and so forth. So this is what the graph looks like. Next, use your diagram to find an estimate of the number of children with a mass of 32 kgs or less. So a mass of 32 kgs or less. So this is my, let's say, 32. So if I have to draw a line like this, it would meet somewhere over here. So it's approximately 38 or 37, you can say. So about 37 children have a mass of 32 kgs or less. The cumulative frequency diagram shows information about the height in meters of each of 100 students. So this is the graph over here. And we are given the height of the tallest student is 1.83 meters and the height of the shortest students is 1.45 meters. So we have the tallest and the shortest values and we are asked to draw a box and whisker plot for the heights of the 100 students. Now to draw the box and whisker plot, you need 5 things. First is the lowest value possible from the data. Next is the highest value. And then you have upper quartile, you have lower quartile, and then median. So you have to know the values of each of these things to draw a proper box and whisker plot. So let's try to derive all these values. The lower and highest values are already given. Let's try to find the rest of the 3 values over here. So here, as you can see, we have the cumulative frequency ranging from 0 to 100 on the y-axis. Now, the first thing that you do is split this 0 to 100 part into quartiles, which means basically in chunks of 25. So let's do that here. So let's say that 21, 22, 23, 24, this is 30. So this is where 25 it probably lies. So let me just draw a line over here and see where it touches. That would be this point. So it touches at 4, 5, 6, 7. It touches at 1.57. Alright. So we got the lower quartile here. This gives us the lower quartile. And then we have the median, which is 50. So here we're gonna draw a line. This is the thing. So this is supposed to be 1.64, that's where the median is. And then the next 75. So 75 would be somewhere over here. Alright, 1.71. That's it. We got our values for each of these. Now we just have to use these values and draw the box and whisker. So on the extreme left, you have the shortest student, which is 1.45. This is the line. And then you have, next you have is lower quartile. Here we can see the lower quartile is 1.57. So this is where the lower quartile is. And then you have the median in between, that is 1.64. So this is where the median is. And then you have the upper quartile, which is 1.71. And then you have the highest value possible, which is 1.83. That's it. So this is what the box and whisker plot looks like. So this is what you do when you have the cumulative frequency graph and you have to change it into box and whisker plot. The first thing that you do is divide the y-axis, divide the cumulative frequency into chunks, so that you have into 25% chunks, so that you have lower quartile, you have upper quartile, and then you have the median as well. And then using those values, you can easily draw the box and whisker plot as shown here. So that's how you answer this 4-mark question. The table shows some values of y equal to 3 plus 4x minus x square, and this is the range of values of x, and you're asked to fill out the diagram for the first question, fill out the table for the first question. So let's do that. This is pretty simple. You just have to take the x value and substitute in this equation. You'll get the corresponding y value. So let me do it for this box. So that would be y equal to 3 plus 4 into the corresponding x is minus 0.5 minus 0.5 whole square, and when you solve this you get y equal to 0.75. So in this box this is 0.75. Similarly, just substitute the values of x, you get corresponding y. So this would be 3730.75. That's it. So that's with the first question. That's how you complete the table, and this is of 3 marks, as you can see. Next, on the grid, draw the graph of y equal to 3 plus 4x minus x square. So now that you have the coordinates over here, use these coordinates, jot these coordinates onto the graph and draw the graph. So this is what the graph looks like. Next, write down an integer value of k for which the equation 3 plus 4x minus x square equal to k has no solutions. So as you can see, the maximum point for this graph is k, y equal to 7. So any point beyond 7 will have no solution. So you can say, let's say 8. So if the value of y is 8, you will have no solutions. Alright, so here we have, by drawing a suitable straight line on the grid, solve the equation. So for this question, there are 4 steps that you have to follow. The first thing is obviously find the equation of the line. That's the first thing that you're supposed to do. Next, using that equation, draw the line onto the graph. Now, after doing this, you'll get 2 points of intersection. So take those points of intersection and find out at what points, at what values of x do they intersect. So let's start with finding the equation of the line. So the way you do it is take the existing equation, 9 by 2x minus x square equal to 0. I'm going to split minus 1 and 9 by 2x, and I'll show you the reason in a minute. So I get 3 minus 4 plus 4x plus half x minus x square equal to 0. So I have 3 plus 4x minus x square equal to 4 minus half x. So I'm just going to take 4 and minus 1 by 2 to the other side. So this is equal to, this is in the form of y equal to mx plus c. So basically I can consider this as a straight line and draw it on the grid. So if this is y equal to mx plus c, what is my m? M is equals to minus 1 by 2 and c is equals to 4. Now, we know the equation of the line, but to draw the line, we need at least 2 points, right? To plot the points on the graph. So let's do that. Let my first point, let's just substitute x equal to 0. When I substitute x equal to 0, I get y equal to 4. I'll show you how. So if we take this, we have y equal to 4 minus half x. So I'm going to substitute x equal to 0, I get y equal to 4. So that's exactly how I got 0, 4. Now let's assume that x is equals to 4, let's say. If x is equals to 4, then y is equals to 4 minus 1 by 2, 4, which is equal to 2. Y is equals to 2. So the other point is 4, 2. So these are the 2 points. So now since I got the 2 points, I can plot this graph and see where it intersects. And it intersects at 2 points. It intersects at 0.25 and 4.25, as you can see from the graph. So this is how you solve this 4-mark question. The diagram here shows the speed time graph of the first 180 seconds of a train journey. Alright, so this is the speed time graph. The first question is, find the acceleration in meters per second square of the train during the first 50 seconds. So this is quite simple. Acceleration is simply delta v by delta t, change in velocity upon time. So as you can see, for the first 50 seconds, the velocity has changed from 0 to 9. So the change in velocity is 9 divided by, what is the time? It is 50 seconds. So it is simply 0.18 meters per second square. That's the acceleration in the first 50 seconds. Next we have, after 180 seconds, the train decelerates at a constant rate of 1944 kilometers per hour square. Show that the train decelerates for 60 seconds until it stops. So here, the thing to notice is we have deceleration in kilometers per hour, whereas we have speed over here in meters per second. So you have to either convert meters per second to kilometers per hour or kilometers per hour to meters per second. So I'm just going to convert kilometers per hour to meters per second. So we have A equal to acceleration is equals to change in velocity by change in time. So T is equals to V by A. We can write this way. Here V is, the velocity is 9 meters per second divided by, what is the acceleration here? That is 1944 into, I'm going to convert this into meters per second. So that's simply 10 cube upon 3600 square. And when we do the calculations, we get T is equals to 60 seconds. This is exactly what they're asking us to show. Next, complete the speed time graph. So as we can see, the time here is still 160, 170, 180. So they've given us until 180 the speed to be 9, but we've just seen that there is a deceleration for the next 60 seconds. So 1, 2, 3, 4, 5, 6. So this is my next 60 seconds. There's a deceleration. So of course there's going to be a downward, a line with downward slope like this. This is the deceleration. That's it. Next we have calculate the average speed of the train for the whole journey. So average speed is nothing but total distance upon time. Now in a speed time graph, how do you find the distance? You take the area under the graph. So if you look at this graph is in the shape of a trapezium. So let's use that and try to figure out what's the area over here. So that is the formula for trapezium, area for trapezium is half into a plus b, which are the parallel sides, into height. So half into the parallel sides, this is 120. If you observe, it goes from 50 to 180, so that is 120, and the length over here, that is 240 obviously. And then you have the height, which is 9. So let's use all those values. We get 120 plus 240 into 9. So D is equals to, when you do the calculations, you get 1665 meters. And the time taken, the total time taken, as you've seen, it's 240 seconds. So let me find the speed here, which is total distance 1665 upon 240, which is 6.9375 meters per second. The table shows information about the height in 8 centimeters of each of 50 plants. So here you're asked to calculate the estimate of the mean. So this is group data, as you can see. So to calculate mean, you just have to multiply the frequency with the height, in this case with the data, divided by the sum of the frequency. So this is summation. So this is the formula for calculating the mean over here. Now, as you can see, we have different ranges of h. So what is the value of h that we should multiply with the frequency in each case? So for that, all you have to do is find the average of upper and lower limit for each box. So for example, for the first box, we have the range between 0 to 20. So what is the midpoint between 0 to 20? That's 10, right? So that becomes my h for the first box. Similarly, for the next box, between 20 to 30, what's the midpoint? It's 25. Next, between 30 to 34, that's 32. 34 to 40, that's 37. And between 40 to 60, that is 50. So now I got my values for h for each box, and I have corresponding values for f for each box. All I have to do is just use this formula and try to find out the mean. So let's do that. You have 10 into 4 plus 25 into 9 plus 32 into 20 plus 37 into 15 plus 50 into 2. So that's my numerator, divided by summation of frequencies. So what's the summation of frequencies over here? That is 4 plus 9 plus 20 plus 15 plus 2. So let me just write it here. That's it. Just put these values in your calculator and you get x bar, or the mean, as 31.2. So that is the value of mean over here. Alright, so here we have a box and whisker plot which shows the information about the marks obtained by some students in a test. Let's just first discuss the significance of different lines in a box and whisker plot. So this line over here, it stands for the lowest number or lowest value in the data. And this extreme right, that line stands for the highest value in the data. So you can say that out of all the marks that were scored by these students in the test, the lowest was 12 over here and the highest was 90. And this line it determines the lower quartile. Lower quartile is basically the first 25, the least 25%. And this line over here, it gives us the value of upper quartile, which is more than, so basically we are talking about students who scored more than 75% of the rest of the students. And this line over here, it gives the median. So the first question that you have, which is write down the median mark, it's pretty straightforward. You just have to see where this line is. It's at 70, so that is my median. 70 is my median. Next, work out the range. Range is basically upper limit minus lower limit. As you can see, my upper limit is 90, the line towards the extreme right, minus lower limit is 12, which is the line towards the extreme left. So that is 90 minus 12, which is equal to 78. That's the range of the data that we're working with. Next, Jay scored a mark in the test that was higher than the mark scored by 75% of the students. So the moment they say more than 75% of the students, we're talking about upper quartile. So where is the upper quartile? This region between these two lines becomes my upper quartile. So we're talking about, this is what, 86 and 90. So any mark between 86 and 90 is considered the upper quartile. So Jay, since he falls in this range, we can just take up any value between 86 and 90, which is, let's say, 88. So that's a possible value for Jay's. Next, we have this box and whisker plot shows information about the marks scored by the same students in a second test. So this is again giving information about the data, about the scores in a test. Now, but this is another test. So let's try to compare these two box and whisker plots. So here, as you can see, my lowest value possible was 12, which means there are students who scored 12 as the least amount of marks possible, and my highest value is going up to 90. Let's try to compare this with this next box and whisker plot. So here, as you can see, my lowest marks is 30. So my starting range is a little higher over here, and my highest marks, it's going up to 97. Yeah. So as you can see, there is a clear improvement in the marks of the students when it comes to the second test. So this is one comparison that you can make. The lowest marks and the highest marks are comparatively higher in the second box and whisker plot as compared to the first box and whisker plot. Hence, students scored better on average in the second test. Alright, here we have a sum on histogram. Let's see what the question says. So some apples are weighed and the mass m grams of each apple is recorded. The table shows the results. So we have a graph, histogram basically, which has data of different masses of apples and the frequency. So let's look at the histogram over here. It shows the information from the table. Work out the value of x. Let's go back to x right now. So this is where x is. So this indicates the second box that you see over here. So from the box, from the graph itself, we can see that the frequency distribution is about this point, which is 7.6. Now we have a formula which is frequency distribution is equal to frequency upon class width. So here frequency distribution we've already taken from the graph, which is 7.6 is equals to what's the corresponding frequency. That's exactly what we're trying to find out. So I'm just going to take it as x as it is and divided by class width. So what's my class width? It's just the upper limit in that class to the minus lower limit in that class. So it's 115 minus 110. So it's 115 minus 110, x equal to 5 times 7.6, which is 38. So this is the value of x, 38. Next we have complete the histogram. So alright, this is pretty simple. You just have to calculate the heights of each of the boxes that you're going to draw. So let's try doing that. Here we have 44 and the class width is 125 minus 15. So let me just try to figure out the height or the frequency distribution. So that is 44 upon 125 minus 115, which is equal to 4.4. Alright, so my box which goes from 115 to 125, it should have a height of 4.4. So let's try to draw that over here. So we have 125 somewhere over here. Yes, this is 125. It's going to go up till 4.4. So this is 4.4. Yep. So this is the rectangle for my third box, this distribution. Next, let's try to find out the height for the last box over here. So what is the last box over here? We have 51 divided by 140 minus 125. So that is 51 upon 15, which is equal to 3.4 approximately. So my next box is going to be at a height of 3.4, and also the width is going to go from 125 to 140. So let's look at the width first. So this is 125 to 140. So my box is going to be this wide, and it is going to have a height of 3.4. So this is 3, 4. Yeah, this is 3. 3.4 would be somewhere over here. So let me just draw a line. Yep, let me rub these. Yeah, so this is my next box. So this is how you complete the histogram. You basically find out the height, or you basically find out the frequency distribution. Both of them mean the same thing. And just plot that in the histogram itself. So here we have a graph of a quadratic equation. Let's look at the question here. So the grid shows the graph of y equal to a plus bx square. The graph passes through the points with coordinates 0, 4 and 1, 1. Find the values of a and b. Alright, this is pretty straightforward. We're given 2 points over here. So let's substitute these 2 points into the equation and try to find out what a and b are. Okay, let's take 0, 4 first. So y value here is 4 is equals to a plus b into x square. X over here is 0 square. So we get a is equals to 4. So that's the value of a here. Next, for 1, 1, here we have 1 equal to a plus bx square. So x is 1 over here. So a plus b equal to 1. Here we can substitute a equal to 4 in this. So we get 1 equal to 4 plus b and b equal to minus 3. So those are the values of a and b. 4 and minus 3 respectively. Next we have write down the equation of the tangent to the graph at 0, 4. So to this graph, the equation of the tangent would be basically, it's just a line that goes like this. We are given 0, 4, which is the topmost point of this graph, and this is a line which is parallel to x-axis. So basically its slope is 0. So if you take y equal to mx plus c, this equation, m equal to 0 because it's parallel to x-axis, and c they've already given, it intersects the y-axis at 4. So your equation is simply y equal to 4. That's the tangent at 0, 4. Next, the equation of the tangent to the graph at x equal to minus 1 is y equal to 6x plus 7. Find the tangent to the graph at x equal to 1. Again, this is pretty straightforward. If you look at the graph over here, this is symmetrical about y-axis, which means the left side of the y-axis is similar to the right side of the y-axis. So in this case, if we have, let's say the graph is something like this, then at x equal to minus 1, we have 6x plus 7. That's the slope. So it's an upward slope. So at x equal to plus 1, it's going to be a downward slope. It's going to have similar slope, but just the sign is going to be opposite. So here we have y equal to minus 6x plus 7. So we're going to change from 6, we're going to go to minus 6. That's the only change that you have to make to find out the equation of the tangent at x equal to 1. Next we have the table shows some values for y equal to 1 plus 5 by 3 minus x, for minus 2 less than x less than equal to 1.5. So this is pretty straightforward. The first question is they're asking you to complete the table. So they've given you the values of x and you just have to substitute the value of x and figure out what y is. So let me do the first grid over here, this box. So y is equals to 1 plus 5 upon 3 minus, what is my x value over here? It's minus 1. So let me just substitute that. I get y equal to 1 plus 5 upon 4, and when you solve this you get answer as 2.25. So let me just write it over here, 2.25. Similarly, for this grid you're going to take y equal to 1 plus 5 by 3 minus x is 0 over here, so I'm going to write 0, and when you solve this you get 2.67 as the value of y. And for this grid as well, we're going to take y equal to 1 plus 5 by 3 minus, we have 1 as the x value, so let's do that. You get 1 plus 5 by 2, which is equal to 3.4. Alright, so these are my values of y. So that's how you complete the table. It's just simple substitution. The next question is, on the grid, draw the graph of y equal to 1 plus 5 by 3 minus x for this condition. So this is pretty simple to do. The reason is, you already have all the points. All you have to do is point, just see where these points lie on the graph, mark them and join those points. So let's do that over here. So this is what the finished graph looks like. Next, write down the values of x where the two graphs intersect. So here you just have to look at the graph, see where the two graphs are intersecting. So they are intersecting at 2 points, at x equal to minus 0.75 and at x equal to positive 0.575. So these are the 2 points where these two graphs are intersecting each other. Next, the answers to part C1 are two solutions of a cubic equation in terms of x. Find this equation in the form ax cubed plus bx squared plus cx plus d equal to 0, where a, b, c, d are integers. So let's do that. Here we have two equations that we are dealing with. The first equation is y equal to 4 minus 3x squared. So this is basically our first equation, this one. And what is our second equation? It is this, y equal to 1 plus 5 by 3 minus x. So let's just write those equations at one place over here. So that's y equal to 4 minus 3x squared. And then you have y equal to 1 plus 5 by 3 minus x. So you can just equate these two because both of them are pretty much equal to y. So you get 4 minus 3x squared equal to 1 plus 5 by 3 minus x. Let's take this one to the other side. You get 3 minus 3x squared equal to 5 by 3 minus x. Let's take this denominator to the other side. You get 3 minus 3x squared into 3 minus x equal to 5. And when you split open the brackets, you get 9 minus 3x minus 9x squared plus 3x cube equal to 5. And let's just rearrange this a little bit and simplify it. We get the final equation as 3x cube minus 9x squared minus 3x plus 4 equal to 0. So if you look at the question again, this is the form that they're asking you to write the final equation in, where a, b, c, d are integers. So if you want to correlate, this is your a is equals to positive 3, your b is minus 9, c is minus 3 and d is positive 4. So this is how you solve the question. Jean asked 600 people to choose their favorite sport, and the pie chart shows some of this information. Now show that 100 people choose tennis. So this is pretty simple. Just take the angle for tennis, that is 60, divided by 360 and multiply it with the total number of people, which is 600 in this case. So that's 60 by 360 into 600. This is equal to 100. So 100 people play tennis. Work out how many people choose rugby. So rugby, again, the percentage over here is 27. So I'm going to divide that with 360 and multiply it with total number of people, which is 600. So I get 45. 45 people choose rugby. Next, 125 people choose cricket and the rest choose swimming. Complete the pie chart to show this information. Alright. So let's say that the number of people who choose swimming, or let's say cricket, is x. So x by 360 into 600 should give me 125. And when you solve this, you get x equal to 75 degrees. So the angle for cricket should be 75. What is the angle for swimming? That's the only option left. So you're going to take 360 and subtract all the other angles, which is 105, 60, 27 and 75, and you get 93 degrees as the answer. So use this information. You'll have, this is, let's say, 75, which is cricket, and this is, let's say, 93, which is swimming. That's it. Next, the height of some plants are measured. So these are the 5 bullet points we're given. On the grid, draw a box and whisker plot to show this information. So all the information is readily laid out for you guys. All you have to do is plot. So we'll start from the extreme left. A box and whisker plot, it looks like this. You have 5 critical lines. This is the lowest value possible. This is the highest value possible. This line stands for upper quartile, this line stands for lower quartile, and this line stands for the median. So let's start with the extreme left. So on the extreme left, we have the smallest height, which is 0.6. So let me just jot this down. This is 0.6. Next, you have the range. Range is 8.1. Okay, so basically range is higher value minus lower value. So you're given the range, you're not given the higher value. So all you have to do is take this to the other side. Higher value is basically range plus lower value. So that is 8.1 plus 0.6. So that would be 8.7. So this is my higher value. Next, the median is 5.2. So let me just draw it over here. 5.2. The lower quartile is 3.4. So that would be somewhere over here. The upper quartile, the interquartile range is 4.1. So the interquartile range is again the difference between the higher and the lower. So if you add 4.1 to 3.4, you'll get the upper quartile range. So that would be 7.5. So let me just, somewhere over here. Now join these 2 points. That's it. So this is how you get a box and whisker plot. Here we have f of x equal to x into x minus 1 into x minus 2. Find the coordinates of the points where the graph y equal to fx crosses the x-axis. So now here the hint is it crosses the x-axis, which means the y coordinate is 0. So in this, I'm going to substitute the y coordinate to be 0. So I get x into x minus 1 into x minus 2 equal to 0. So in this case, x can be equal to 0 or x minus 1 equal to 0 and x minus 2 equal to 0. These are my 3 values of x. So this is 0, 1, 2. So I can have, for y equal to 0, I can have 3 values of x. So basically the points are 0, 0, 1, 0 and 2, 0. This is where the coordinates of the points cross the x-axis. Next, show that f of x equal to x cube minus 3x square plus 2x. For this, all you have to do is just open these brackets and simplify the expression. So you get x into x minus 1 into x minus 2. And when you open the bracket, you get x square minus x into x minus 2. And open the bracket further, you get x cube minus 2x square minus x square plus 2x. And you get finally x cube minus 3x square plus 2x. This is what exactly they're asking in the question. Next, find the coordinates of the turning points of the graph y equal to f of x. Show all your working and give your answers correct to 1 decimal place. Now, to find the turning points, all you have to do is find y dash, or basically the first derivative of the function, and equate it to 0. So let's do that. Here you have f of x, or y is equals to x cube minus 3x square plus 2x. So let's start with finding the first derivative first. That would be 3x square minus 3 2s are 6, 6x plus 2. Now I'm going to equate this to 0 to get two values of x. So let's, this is a quadratic equation, so we can use this formula x equal to minus b plus or minus root over b square minus 4ac by 2a, which is minus of minus 6 plus or minus root over minus 6 whole square minus 4 into 3 into 2 by 2 into 3. When you solve this, you get 3 plus or minus root 3 by 3. Now let's convert this into decimals for the ease of calculation. So 3 plus root 3 would be 3 plus root 3 upon 3 would be 1.6. 3 minus root 3 upon 3 would be 0.42. So these are my two values of x. Now we have the values of x, we just have to find the corresponding values of y. And how do you do that? Just substitute the values of x in f of x. So f of x is equals to this, right? So instead of x, let's take 1.6. So that would be 1.6 whole cube minus 3 into 1.6 whole square plus 2 into 1.6, which is equal to minus 0.384. So that's the value of y if x equal to 1.6. Similarly, let's take f of 0.42. So if x equal to 0.42, what's the value of y? Do the same thing, just substitute 0.42 instead of x, you get 0.384. So let me just write it clearly over here. When x equal to 1.6, y equal to minus 0.384, that's one value. That's one turning point, and the other turning point is x equal to 4.2 and y equal to 0.384. This is another turning point. So these are the two turning points that we have. A dice is rolled 100 times. The frequency table shows the result. So this is the frequency table. You have the score and you have the frequency. Find the range. Range is pretty simple. The upper score minus the lower score is the range, which is 6 minus 1, which is equal to 5. Mode. Mode is the value with the highest frequency. So what is the value with the highest frequency? This is the highest frequency and the corresponding value is 2. So this is my mode. The median. So median is the mid value. So as you can see here, the mid value, the middle observation lies over this zone. So I get the median as 3. So median is basically, if you were to lay out all these scores from lower to higher, basically in ascending order, what is the middlemost value? So for me, it falls in this box where the score is 3. So that's my median. Next, 50 students answer a mathematics question. The table shows the time t seconds taken by each student to answer the question. Calculate an estimate of the mean. So this is pretty straightforward. To get the mean, you have to multiply the frequency with the x, the observation, summation of frequency with the observation divided by summation of frequency. This is how you get mean. Now if you observe, here the observation is not a singular value, it's a range in each box. So how do you get a single value? You just take the average of these two. So for here, the average is what? 15. And here the average is 22.5. Here it's 27.5. Here it's 40. And here it's 65. So now you have the values of x. And you have the frequencies as well. So let's go ahead and use this formula to find out the mean. So that would be mean equal to 2 times 15 plus 22.5 times 8 plus 27.5 times 12 plus 40 times 16 plus 65 times 12 divided by summation of frequencies. That's 2 plus 8 plus 12 plus 16 plus 12. So when you do this calculation, you get mean to be 39.2. That's what the mean here is.